Hello, everyone. I think we are live. And first of all, thank you everybody for joining. Today we continue in series of our webinars dedicated to agribusiness, and today we're going to speak about carbon. To be precise, about soil organic carbon and how to cultivate soil organic carbon. And if you guys can hear and see us, if you could please put a plus sign so we know that you can see us. Okay, sounds good. So we know that we are live, and as I mentioned before, the topic of today's webinar is carbonizing soil, and we're gonna speak about carbon. Also, I would like to introduce our guests. We have Andrew Bremner, National Innovation Manager from AgriProve, who is joining our webinar today. Andrew, glad to have you here. Thank you for participating.
Yeah, thank you, Yevgenii. I hope everyone can hear me. It's a pleasure to be invited along. Thank you for hosting. And I look forward to covering the work that we've been doing together. And it's exciting to be able to do it across the globe. So, thank you.
Sounds good, Andrew. And definitely, yes, we have pretty packed agenda. So without any further hesitation, we're going to go ahead with the agenda. I would like to introduce our other guest. This is Oleksandr Kryvoshein. Oleksandr, he is senior researcher at EOSDA, and Oleksandr today he will be providing his scientific expertise on the soil organic carbon models and how they work. So basically, the complex things under the hood. Hi, Oleksandr. How are you?
Hi, everyone. Thank you. I'm good, and have a good webinar. Enjoy the webinar.
Thank you, Oleksandr. Also, we have here Kirill's as our moderator today. So, guys, if you have any questions during the webinar, so please leave them in chat. And at the end of the webinar, we will have a good 10-15 minutes, and we'll try to answer all of your questions. And now, without any further hesitation, I would like to briefly go through the agenda that we have today. So, first of all, I will briefly tell about EOSDA for those of you who's joining and watching our webinars for the first time. So basically, background on the company. And then Andrew will tell us the story of AgriProve, because AgriProve is one of the largest and the most experienced soil carbon project developers in Australia. So basically, Andrew has a lot that he can share with us today. We'll speak why it's important to focus on the soil organic carbon, what are the benefits for farmers, what are the benefits for combating climate change. We will have a look at the Australian soil carbon method and framework, since AgriProve is operating in Australia. And for those farmers and maybe other participants from Australia who are thinking about to participate in carbon projects, this is the information that could help to answer a lot of questions and help to make them a decision. Also, we will speak about the project that we're currently doing with AgriProve. This is the National Innovation Soil Challenge. This is the grant from Australian government, which is aimed at the reduction of the verification costs for carbon projects. So we'll tell what we do within the scope of this project and what are the results and what are the final outcomes we can expect. And we will actually focus a little bit more in detail what are the advantages for the farmers to participate in carbon projects, and how these projects would help them to, first of all, improve the health and quality of the soil, but also how we could address the climate issues that we have right now. In more details, Oleksandr will tell us about AI and machine learning solutions for the soil organic carbon sequestration, how actually the models work, what predictors goes into the model. So you will see that this is not easy or simple solutions. This is complex solutions, but I think that we'll be able to explain it and show a little bit more science behind the modeling and how it's done. And at the end, we will basically sum it up and make the conclusions, what is the future and what are the benefits of using the models, and how it can help us to scale carbon projects in Australia and globally to really make it a tool that could help us to address the climate change. And at the end here, we'll have Q&A session. So guys, please go ahead and feel free to post your questions in chat. Yeah, a few words about the EOSDA. So EOSDA stands for Earth Observing System Data Analytics, and we provide AI analytics based on the satellite imagery. Our company itself is headquartered in United States, California, and also we have R&D centers and scientific centers across the Europe. I think that the strong point of the company that we have a very good scientific team, which basically generates and contributes to the innovation that we drive in EOSDA. We work with different companies, governmental institutions, scientific organizations. We participate in tenders and basically working on providing remote sensing to all the stakeholders which need to have this information for their objectives. And here you can see actually the involvement of the company. It was founded in 2013 by Dr. Maxim Polakov. In 2015, we have established the foundation for the company. This is EOS processing and EOS platform upon which we have built and building our solutions. In 2016, we have our first product, Land Viewer, which were released, and this is all-in-one platform where we have access to open source data as well as to multiple high-resolution providers. This data could be get on the fly for any location in the world. Plus, we have analytics, different analytics, which could apply to the imagery. So very cool tool. We have a lot of forestry and GIS specialists who's using the platform. So definitely, I recommend to check it out. In 2017, we have released our flagship product. This is a crop monitoring platform. And since 2017, we keep improving and innovating this platform, adding new functionality to make it well-rounded solution, which could be applied not only for monitoring and managing the croplands, but also in this example, and we will tell you a little bit more how it is used in carbon projects. From the latest improvements in the crop monitoring platform, we have disease risk module that we added to the platform for more than 20 diseases, so the platform could predict the diseases. And also we have biophysical yield estimation calculator, which is also available in the platform to give the prediction on the fly for 14 days of the expected yield outcomes. Since 2018 to 2022, we have other unique deep learning models developed in the company, including crop type classification, identification of the field boundaries, development of soil moisture product, as well as yield estimation models, and early development and application SOC and ROC models. In 2022, we also have released forest solutions, including deforestation, reforestation assessment, and recently we developing solution for EUDR policies. 2023, it was a big milestone for our company, and we have EOSSat-1 that been launched for EOSDA, so we have proprietary satellite and access to our own data. And of course, starting from 2022, we have collaboration with AgriProve, and we are jointly working on this project right now for the Soil Innovation Challenge, and we will speak about this innovation challenge a little bit more further in the presentation. As I briefly said, the main products that we have, this is crop monitoring platform, which is used for monitoring the agricultural land as the analytics tool, but also applicable for other projects, for example, like carbon projects as well. And a set of custom solutions that we deliver as crop classification, identification of the field boundaries, yield estimation. For example, from the latest models that we adapted for the yield estimation, this is Spice-Avit model for estimation of the yield of oil palms. So as you can see in EOSDA, we keep developing and innovating and offering new solutions for different geographies to make sure that the remote sensing data is serving for the purpose of businesses and basically for the all humankind. And now, I just wanted to pass it over to Andrew. So Andrew, if you could please also tell us, first of all, a few words about your team and how AgriProve, how you become the most larger and the most experienced soil carbon developer in Australia.
Yeah, thank you, Yevgenii, and hi again to everyone. I'll just go to the, oh, sorry, I jumped. There we go, sorry. Needed to get the slide. Yeah. Hi, everyone. Thank you again for joining us. And yeah, it's a great pleasure to be here today to discuss the exciting work that we have been involved in. And yeah, we'll learn a lot more about it. I did want to start by saying too how proud and humbled we are here at AgriProve with just the number of farmers that trust and partner with us in their soil carbon project journey. So AgriProve has been in operation since 2018, and since then we have over 700 soil carbon projects registered under the ACU scheme. This represents more than 75% of the active soil carbon projects in Australia. The map on the screen shows the spread of these projects. And as you can see, the red dots are the projects which have been awarded ACUs, or Australian Carbon Credit Units, and there's 8 in total there now. The yellow dots are the projects which have had a measured positive increase and are in the final stages of auditing and review to be awarded ACUs, with a total of 59, actually I think we're a bit over that now, 62 as of this week that are waiting for ACUs. And then the green dots are the remainder of our projects. Those that aren't familiar with Australia, the majority of our farmland is along the eastern seaboard and the western areas of Western Australia. And you can see that reflected by our project locations, with approximately 75% of those are under livestock and grazing operations, and the remaining 25% are under cropping systems. I'd also like to provide a bit more about our team. We are a group of very passionate and highly skilled people, with over 30 in the AgriProve team. And a little bit more about me. I'm, as Yevgenii mentioned, the National Innovation Manager here at AgriProve, and I lead the Technovation team, which really we focus on a wide range of areas of innovation, but ultimately on how we can grow and scale the impact of our business, and more broadly, the impact we can have in addressing climate change through soil health and soil carbon.
Definitely, Andrew, this is great.
I'll provide a bit more too about the history of AgriProve. And so really the genesis of AgriProve was the work and the involvement from a company called Corporate Carbon, where a number of the early soil carbon projects began. From there, a new company, AgriProve, was born in 2018, with really the sole focus on soil carbon. Our founder and CEO was also involved in the development of Australia's first soil carbon method as part of the Australian government-backed Emission Reduction Fund, which is now known as the ACU scheme. We have a bit of a saying at AgriProve, and it's the power of one. And a key milestone on demonstrating really the possible, and one we're very proud of, was the successful measured increase of soil organic carbon and ACUs under the Australian soil carbon method in 2018. And really from there, little things, from little things, big things grow. And we've seen continued engagement of farmers and the broader industry to see the importance of soil as a carbon change solution, as well as promoting more resilient and profitable farming systems. In 2020, we reached over 100 projects in the AgriProve portfolio. And in 2021, the soil carbon method was released, which the 21 method was released, which further advanced the robustness and built in more specificity in farm management activities and how to quantify soil organic carbon. And this ultimately added further integrity to the Australian soil carbon credits. This revision of the method also introduced the ability to incorporate modelling into the quantification process, and we'll talk more about that. In 2022, a government initiative was launched with the challenge to reduce the soil carbon measurement costs to under $3 a hectare. And as part of this challenge, AgriProve and EOS were the successful grant recipients of a $9.2 million grant, really to investigate the multiband SAR and optics as a novel soil carbon measurement technology. And that really allowed AgriProve and EOSDA to continue to develop our partnership, which has continued to flourish. And it's really driven a lot of the work on collaboration of the soil organic carbon model, which we'll cover in more detail. And then in 2024, as I mentioned, we've reached over 700 projects and over 150,000 hectares under soil carbon within the AgriProve group. So really, this is just a small amount to what we see as necessary on our mission to sequester 1 gigaton of CO2 by 2030. And what is really needed as a climate change solution. I think the future is bright and the momentum continues to build.
And Andrew, yeah, I would like to pause it here maybe just for a brief moment. And as you mentioned before, so the CEO of the company and the founder of the company, Matthew Warnken, he was one who actually at the very beginning participated in developing Australian carbon method. Is it correct?
Yeah, Yevgenii, that's correct. So yeah, he was involved very early and was the founder of AgriProve, and has really been a driving force to what we see today.
Yeah, this is actually what I wanted here to point out, that AgriProve, basically you have all this knowledge and wisdom in your team, and basically you, more than everybody else in Australia, could understand what it takes to develop successful carbon project. And speaking about your carbon projects, I know that 2 of your projects recently been awarded carbon credit. So if you could please tell us, and for those audience who's hearing us, what it actually take to develop successful carbon project. How long does it take from the moment that, for example, farmers, you onboard the farmers to the moment of receiving the certificates?
Yeah, certainly, Yevgenii, and yeah, let's take a look at what it looks like for a couple of example projects, and these ones are the ones that have recently received credits or ACCUs, and yeah, how they look on the ground. So I'm showing 2 on the screen here, but I encourage you, people listening in, if they're interested, we've got case studies listed on our website as well. And there's links down there on the screen that you'll see. So a quick snapshot. The first one is the Hausen Carbon Project. It was baselined in April 2022, so that's the first round of sampling. It's a larger property or group of properties. It's 8,000 hectares or about 20,000 acres, and it's located in central Queensland, state of Australia. It's actually near a place called Banana. So people that aren't familiar with Australia, that is a real town name. And they're running a cattle operation consisting of about 3,000 head of cattle with about 900 breeding cows. And their land management strategy has been very much focused on incorporating rotational grazing and proactively matching their stocking rates to carrying capacity. They have also invested in a range of water and fencing improvements to achieve this, as well as grass and legume pasture improvements. And as a result of their work and being part of the soil carbon project, they've received just recently in June 9,214 ACCUs, and they've also achieved beyond net zero carbon intensity. So their sequestering is exceeding their emission levels. The next project shown there is the Lynch Carbon Project, and it's in Willow Creek, South Australia. It's a intergenerational farm running about 100 breeding Angus cows on about 156 hectares. And they have focused on pasture improvements as well as soil renovation using a soil key renovator, which is a soil renovation system, and subdivided their paddocks to allow higher intensity rotational grazing. Through this work, they've seen significant soil health benefits and have been able to reduce their fertiliser and spraying requirements to almost nil. Within 2 years of the Soil Carbon project being active, they've received 641 ACCUs and have also been able to sequester more carbon each year than emitted, which is allowing them to reach beyond net zero carbon intensity.
Basically, Andrew, by looking at these projects, we could understand that it really doesn't take a lot of time from the start of the project actually to issuing carbon credits. So farmers could be confident within a couple of years if they follow the methodology and basically do all these positive land management practices, so they could expect to get paid for their work and basically be awarded the carbon credits.
Yeah, that's right, Yevgenii. It's these are good examples of really active management, and they've been able to measure gains in their soil organic carbon levels, which equate to ACCUs. So pretty fast results for these two projects. The soil carbon project under the method we operate under is 25 years in length. So there's plenty more time ahead too.
Understandable. And speaking about the measurement, on the next slide, Andrew, I would like to also comment, as I understand that also at this screenshot, we see one of the projects, Hobson project, that was awarded, and the interesting thing that we are looking at through the crop monitoring platform. So I just wanted to ask how you've been using the crop monitoring platform and basically all the other technologies from EOSDA for implementation for the carbon projects.
Yeah, definitely, Yevgenii. This is the Hobson carbon project, as we mentioned, showing on screen. And we do use a range of digital tools, right throughout all the stages of our project, from registration through to baselining, which is the first sampling activities, then through the measurement and implementation, and right through to the crediting of soil carbon projects. When we begin a soil carbon project, a really important piece is assessing the area and setting it up so we can effectively measure and monitor it through the entire life. And part of this setup is dividing the project into areas and zones that form the management areas, as well as the areas that we need to monitor and measure. We do rely on EOSDA's crop monitoring tools and systems to help us understand these areas. It really allows us to build a history, looking at the historical biomass and climate trends, as well as often infer some management history there as well. We also look at this information to help define and build the zoning, which under the carbon project is known as strata for the carbon projects. Once a project is in play, we use crop monitoring to help us track the changes and activity over time, as well as monitor the overall performance. This can also be a valuable tool for the farmer, as it provides insights into the performance of their carbon project and can also allow them to assess the impact of their management actions in more real time. To quantify the change in soil carbon, we take physical sampling and lab testing at intervals through the project, and this can be undertaken as soon as 1 year after the previous sampling round and as long as 5 years after that sampling. And it is a reasonable investment to mobilise our sampling teams and to invest in the sampling itself. And we want to make sure that the project is ready and it's worth the time and cost to do so. So to help us make that decision, we use crop monitoring as really what we call a lead indicator assessment of the SOC sequestration. And we're comparing trends to the baseline and prior and trends after the baseline period. And it's really important, as you can see on screen here, that we can assess that both in a spatial distribution, so that map sort of view, as well as the temporal changes or the changes over time. So yeah, the crop monitoring tool is a very useful tool for us. And we also do use it more broadly for our entire portfolio of projects. So, as we mentioned, over 700 projects there, quite spread across Australia. And it's a significant barrier to travel and access those all the time. So being able to do this in a remote way is really useful.
Andrew, just wanted to add, basically, you pointed out correctly. So this the platform, the crop monitoring platform, could be as the single source of data, and the access also could be given to farmers, for example, in future when we can display the soil organic maps or precise soil maps. But the advantage, as you mentioned correctly, this is the scalability. So we could check any property located anywhere in Australia or in the world on the fly with the access to historical data. We could have a look at the vegetation indices such as NDRE to understand the length and the basically the activity of the photosynthesis to understand if this is the suitable properties for participating in carbon credits. So definitely, satellite technology can help, and we will tell what we are planning to do in future, how we're planning to enhance this technology. And now, maybe from the broader point of view, we would like to dwell a little bit more on the benefits and actually why we should focus on the soil organic carbon on the broader view. So Andrew, if you could please maybe just walk us through this slide and tell us what is the importance actually to focusing on the soil organic carbon.
Yeah, thanks, Yevgenii. Yeah, absolutely. So, our strong belief at AgriProve is that soil carbon is a necessary part of the climate solution, and I'll explain that in a bit more detail. So, as you can see on screen here, it's a visualization. But soil is the largest terrestrial carbon pool, so or storage. So that's shown soil in the orange there, compared to the above ground biomass, vegetation, and the animal pool as well, the light green. So as you can see, soil carbon is the largest in all those landscapes, and it represents approximately 4.5 times that of the tree and animal biomass, and it's almost 2.5 times more than the atmosphere and living flora and fauna combined. So pretty significant. And the important piece here is that soil is under, or something we can impact, so it's under human management. Soil has been degraded over time, and the carbon amount in soil reduced, which scientists agree that this is primarily due to human intervention and practices. Now, why that is alarming, it also represents a potential solution, with management being the way to be able to reverse this depletion and regenerate our soils. We also see the right management can provide many other benefits as well. So increasing soil carbon in improving soil health also stands to improve many other ecological aspects. So, enriching the biological activity, increasing plant nutrient availability, increasing the water holding capacity and plant available water, and more resilience to drought and flood conditions, as well as healthier ecological habitats, to name a few. When we consider the nutrients from soil that pass to the plants that are grown and the livestock that feed on it, it's pretty easy to see that healthier soils can create healthier food sources as well. So furthermore, more resilient and healthier farming systems are also integral into sustained food security, particularly in the climate that we're really experiencing and observing rapid change. So all that combined for us at AgriProve, when we look at the scale of the challenge to meet the climate change targets, and that's, according to the Paris Agreement, to limit global warming to under 1.5 degrees, we see it'll be necessary to reduce emissions and also sequester carbon. And to sequester the required carbon, soil carbon is not only an important carbon sink, but in fact it is really a necessary, where the amount of carbon needed to remove from the atmosphere will need soil in that solution. So it really is must be part of the solution if we are to achieve global warming targets.
Andrew, cannot agree with you more, absolutely. So here, as we see that terrestrial carbon, this is something that we have control over. So basically the land been calculated by humankind since 4000 BC, and we see that agriculture actually contributes 2/3 to the atmospheric pollution. So this is something that definitely we have control over, and the whole direction is here to change the practices that we do in agriculture to make it more sustainable, so we could leverage our basically influence on the terrestrial carbon and make our soils also the solution for this complex problem. And if we have a look in more granular way at the benefits and the solution, so basically, could you also tell us what are the benefits of cultivating carbon, first of all, for emission reductions, for the climate benefits, but also what are the benefits for farmers and basically the companies who's developing carbon projects?
Yeah, certainly, Yevgenii. Sorry, main connection just went. Can you still hear me?
Yeah, it's breaking up a little bit, but yeah, we can hear you.
Yeah, cool. There are many reasons why we should focus on soil carbon solution, and also why a is required. We mentioned some of those before. I'll go into a little bit more detail. Really, as mentioned, soil has the capacity to sequester all
Andrew,
the emissions necessary.
I'm sorry, Andrew, you're breaking up. I don't know, maybe there is a chance to switch the network, because you're breaking up and now it's getting a little bit worse.
Yeah, sorry, Yevgenii. Is that better?
Yeah, it's much better. Yeah, please go ahead.
No worries. As we mentioned there before, soil has the capacity to sequester all the emissions necessary to remain below that critical 1.5 degrees of global warming. And it really represents, I believe, a rare win-win scenario where removing carbon from the atmosphere is also beneficial for climate stability, but it has so many other benefits for farm productivity and farming systems as well. So it's not always possible for emitters to completely eliminate all their emissions. So being able to decouple the emission sources from where emissions can be sequestered through a crediting system, is also important to be able to address these issues at a macro level. But yeah, as a climate change resilience piece, to name a few, soil with higher carbon is also naturally more aerated and can hold and retain more moisture. So this means that it's more effective in soaking up moisture, particularly in intense rainfall periods, or also in drier periods. So this increases the resilience of soils to the extremes, the resilience of farming systems as a whole, where pasture and crops can survive and remain active. Increased soil organic carbon and organic matter provides diverse energy sources for soil microorganisms as well. So supporting greater soil biodiversity has many benefits, including increased plant access to moisture, buffering soil acidity, improving soil structure, greater availability to nutrient through mineralization, as well as resilience to physical degradation. So it can also play an important role in reducing the resilience of disease and pest inputs through improved function of natural systems. And we saw examples of that from the Lynch Carbon project, where they were able to reduce their inputs to pretty much zero. And there are also many other co-benefits. So as value to the economy, as a contributor to that, can provide additional income pathways and also reward farmers for practices that are focused on long-term sustainability. There is also a growing consumer demand for food produce in environmentally sustainable ways. And through these practices that combat net emissions can allow premiums to be sought by producers and also new market access. So yeah, they're just a few of the benefits, but yeah, they really stack up and really, soil carbon is such a great opportunity, we believe, for all these reasons.
Yes, Andrew, and as we can see, so the cultivation of soil carbon, first of all, for the farmers, it could be additional stream of income, and I think more important, so by doing all these beneficial practices, actually farmers could enhance the health of the soil and thus at the end increase the yields that they could get from their farms. And also we know that not all the methodologies, not all the protocols are the same, and also not all the carbon credits are created equal. And we understand there is, like a large variety of the approaches and also to methodologies that could be applied to the carbon projects. And at this screen, I just wanted to ask you if you could tell us about the Australian carbon method. As I understand, so this is a regulated market in Australia, controlled by the Australian government. So, and the methodology and the bar for the carbon project in Australia is probably higher than if we compare it to other projects. So, Andrew, if you could tell us what are the differences and what are the advantages of the carbon methodology that you do in Australia?
Yeah, good question, Yevgenii. And you are correct that it's a compliance market under the Australian government. And we're most familiar with the Australian soil carbon method, but there are many other methods and frameworks around the globe. So since the Paris Agreement in 2015, there have been quite a number of carbon markets evolve, both at a national and subnational level. And most of these are voluntary-based markets. A recent review, and what we're showing on screen, was conducted by an independent non-for-profit group called Carbon Plan. And their goal is improving the transparency and scientific integrity of climate solutions. And they assessed soil carbon protocols across the globe. And if you're interested to find out more information, you can. There's a link at the bottom of the screen there, or you can search Carbon Plan, and you should be able to find it. And the Australian carbon method is a measurement-based approach that requires physical soil sampling, and it seeks to drive accuracy in measurement, validate really genuine abatement, and provide high integrity credits. So while operating in a high integrity framework is ultimately beneficial for the market, for those that generate the credits, though, through sequestration, and those that trade and purchase credits as well, it does pose some challenges, and we'll talk more about that. Particularly with being a physical sampling based system, it can create more cost to sample that. So it does require careful consideration to achieve really cost-efficient measurement and also to be able to achieve it at scale. It's a challenge that AgriProve we gladly accept and continue to work in this framework. But yeah, the Australian soil carbon method was ranked the highest across the globe for rigour and integrity.
So yeah, we can see that this is one of the most, I would say, strict and methodologies which has the highest bar. And also, if we're speaking about the carbon method itself, maybe for those for the audience who's watching us from Australia, for those farmers who are thinking about to participate in the carbon credits, Andrew. So could you tell us about the rules of the carbon methodology according to which the projects are done in Australia?
Yeah, it is probably good to understand some more of the specifics there. So as I mentioned, the method is primarily a measurement-based method, and the first soil carbon method was released in 2014, which is 10 years ago now, and since then it's been revised in 2018 and 2021. It does, so as I mentioned, it is a measurement-based model, but it does have provision for some measure model approaches as well. And that's important as we talk more about the SOC model and how that fits in. An important part of the design is to promote practice change that creates increase in SOC over time. It is for agricultural land, and the land must remain in active ag production. So there's some key points. There are a number of eligible activities that can be implemented, and they must be new activities or materially different for that area. So that's to ensure that it is practices and things that are being introduced rather than what was going to happen anyway. And so SOC is measured directly through field collected samples. And from there, I want to talk about how the projects are broken down and how they operated. And again, this is as we look to how a model can help us. It's important to understand some of these key pieces. So a carbon project is divided into what's known as carbon estimation areas, or CEAs. And that's the level where the SOC or carbon stock is calculated for each of those areas to give the total carbon stock for the project. And to measure SOC at these levels, at the CEA, it's broken into 3 strata, or a minimum of 3 strata. And from there, samples are taken in each of those strata. And again, there's a minimum of 3 samples in that strata area. The interesting piece here is that the sample locations are randomized within that strata. And that's really to avoid the possibility of focusing on a known sample location and not carrying out those activities across the whole area. Those samples are collected and they're measured in a NADA-approved lab, and SOC percentage is measured through a loss of ignition type testing. And then all these samples are used to estimate the soil carbon per strata. And a confidence deduction is applied according to the variance of results of these samples. So if samples are close in value, then there's a high confidence that they accurately represent the SOC amount for that overall stratum. The strata SOC levels are combined, then take into account the sample variance to calculate the mean SOC level for the CEA. So when a project begins, we do a baselining sampling round, and the change in SOC is then found after another sampling round, and it's the difference between those two measurements gives you the change in SOC. And ACCUs can be awarded on change of SOC after a number of other discounts that consider permanency and the possibility of reversal are applied. As I mentioned before, the subsequent sampling rounds can be conducted as early as 1 year and as long as 5 years after the previous sampling round. Now, under the method, stock must be measured to a minimum depth of 30 centimetres, but at AgriProve we actually elect to sample and quantify to a metre and a metre plus where we can. And really that's because we're interested in change over time of carbonate depth and also the longer term permanency of that soil organic carbon. And projects are 25 years in length, and each application for credit requires a comprehensive independent audit, and there's also some project details and results are reported out.
Thank you, Andrea. So yeah, we can tell that the projects, they're not simple. So this is the complex project, and for those farmers who would like to participate, definitely they need to have some guidance and support, which AgriProve can provide. And here, briefly, I just wanted to focus on the advantages of using the models at each of the steps. And as you, Andrew, already mentioned, so models could help us to eliminate guesswork, because most of the time, projects onboarded blindfoldedly, so we do not know the potential of the projects, and this could be only find out after taking the samples and further into the project. So basically, what modeling could do, possibly modeling could provide us better assessment of the project even before doing the baseline. So based on open source data, precise soil maps, we could already make a better estimation of the project even before like setting foot into the field. Another one, yeah, this is, as you mentioned, this is stratification and covariance, because samples are taken randomly. And what models could help us to do, models could help us to create more precise strata. So we have less covariance, less stratification, meaning that the samples taken within same strata will show less covariance. So this is less penalties and basically more income for the farmers. And on the third step, yeah, the duration of the project is 25 years, so definitely validation samples round could also be expensive and could affect the final profitability of the project. So here, by using the models, we could reduce the samples, the verification samples up to 90%, meaning that 10% is physical samples, which are still needed, but 90%, which is a significant amount, could be replaced by modeling. And in this case, we need to have robust basically commercial model which can show us a good results. But again, yeah, speaking about taking samples and stratification, Andrew, if you could comment this slide, because it looks pretty interesting and pretty complicated. So as I understand, this is one of the projects where you actually taken samples, and here we could see different stratas, or what exactly we could see in this picture with different colors.
Yeah, certainly, Yevgenii. It's really highlighting what we mentioned there of the structure of a typical soil organic carbon project and how it looks in practice. So as you can see, areas that aren't farmed are not included, so they're removed. And you can see, or hopefully you can see, how the project areas have been divided into CEAs. It's maybe a little bit difficult on that one, but there's three CEAs, and then further into strata, which are the coloured zones there. So the yellow, the purple, and the light blue. And then again, maybe a little bit difficult to see on screen there, the sample locations. So they're in the blue, black and blue text, and there's a little crosshair to show where those samples are. And you can see they're quite distributed across that area. So yeah, in structuring those CEAs, we often find it's most useful to focus on really the management areas, and areas that are under different management practices or management zones to group those. When we look at the strata, really we're trying to group by the underlying soil organic content or soil organic change potential. And to do that, often we don't know beforehand, before the baselining. So this is where utilising some predictors or other measures that we can use to help understand that is really beneficial for us to be able to then create these zones or strata in accordance to that. So you can see they're much more following curved type zones and following environmental or underlying soil properties rather than farm boundaries and things like that. So yeah, that's a good example of how we break projects up.
Thank you, Andrew. And now, actually, we would like to switch to what we're doing jointly about the National Innovation Challenge and how AgriProve and EOSDA, by combining our knowledge and also experience and access to the ground data, as well as satellite technology, how we actually contribute to the goal of the National Innovation Challenge. This is the reduction of the cost for validation. So, Andrew, if you could tell us, what basically the contribution from AgriProve and how we jointly contribute to, I would say, innovation and basically breakthrough for development of this new technology.
Yeah, thank you, Yevgenii. So as we mentioned, we've been working together since 2021, and really through this time we've identified some various strengths and really a shared vision of supporting farmers and providing tools and systems that help increase their productivity and also new ways of combating climate change and land degradation challenges. So it was a very natural fit with our unique skills and areas of expertise to come together on this. At AgriProve, we hold and continuing to grow really one of Australia's largest soil databases. And we've got in excess of 20,000 physical samples there now. And then EOS, with their expertise in remote sensing, satellite imagery analytics and machine learning capabilities and modelling capabilities, really helped us converge on what we see as this opportunity here. A number of things we're trying to solve for and continue to understand, and particularly being able to do it in more of a remote fashion. It made a lot of sense for us to look to combine the value and the power of or potential power of all these physical samples with the state of the art modeling and machine learning capabilities.
Thank you, Andrew. And definitely this is so because it's only possible to do in collaboration. And one of the most important things for creating these commercial grade models, this is actually access to the good ground data set and being able to train the model locally. And the innovation, this is the application and introduction of the satellite data. And specifically in these projects, we're doing a lot of experiments with the high resolution optical and the SAR data, synthetic aperture radar data, to see how these new predictors could contribute to the accuracy of the model. So there is a lot of experimenting going on, and definitely I think that we will get good results at the end of the project, and definitely will be able to contribute to reduction of the cost of the validation. But again, it's only possible to do it jointly by having, data from space, but actually the possibility to verify this data on the ground, because those two, they go hand in hand, and to understand how we could apply data, satellite data, we need to understand what's happening on the ground. And this is what AgriProve is helping us to providing the extensive ground data sets and basically their observation. Speaking about what we could, what challenges we're solving with the modeling and application of this new technology, and actually how this could help to the farmers. So first of all, as Andrew outlined before, so one of the challenges is to establish a accurate baseline at the beginning of the project. Then this is the compliance of the projects, adding additionality, so to introduce new practices which could help to contribute to the SOC accumulation in the soil. This is a reduction of the verification cost. So once we have established baseline, so we need to have the verification, and this is also another big line of expenses which actually taken from the profitability of the final project. And another one here, this is the variance. So if we have like high stratification between different zones of the project, so in this case, we know that it could be penalized, and basically it will also reduce the payoff for the farmers at the end. So the solution, this is application of the remote sensing, the creation of precise soil maps, the precise maps of the distribution of the soil organic carbon, and the application of vegetation indices and other data which could help us better understand all these factors. So as an outcome, we could have much better information that we could use to basically be able to eliminate, for example, the covariance or the stratification, as well as reduce the number of physical samples. And of course, at the beginning of the project, being able to understand what projects are have high potential and they could generate more credit. So basically focus on those projects. And for the farmers, of course, here we're speaking about for us being able to understand what activities contribute to increase of SOC in the soil and for the sequestration of CO2. So basically, by getting more and more feedback from the actual activities done on the farms, either it's a pasture or croplands, we could provide better recommendations to the farmers based on the results of the models and physical samples, what activities are working. So the platform, crop monitoring platform, which will eventually comprise the SOC model, could be as a decision tool, which could be shared with the farmers. So that would be like the platform connecting AgriProve and the farmers and exchange of the information. Also, the models will help to reduce the barrier to entry the project. So basically, lowering the cost of sampling, it will allow more farmers to participate, and basically this is what we're trying to achieve. We're trying to achieve scalability, because by having few projects not gonna affect the climate change. We need more and more farmers and landowners to basically contribute to this and adopt and become cultivating carbon. Another one, this is the possibility of us better understanding the levels of biomass by using the models and maybe providing more advisory to the grazing management guidance to tell when the lot of land should be grazed, how much time it should be given for rest, for restoration, and so on. And another big one, this is increasing the frequency of crediting. So from the previous example, we could see that, for example, Hobson project, it was credited after 2 years. But if we know, if we have the precise model, and this model could precisely tell us that, for example, we already have significant increase in the content of SOC over 1 year. So this means that instead of paying in 2 years, farmers, they could get paid every year, so more frequently. So by having precise understanding how organic matter behaves in the soil, we could actually increase the profitability and basically the cash flow for the farmers by having the payouts on annual basis rather than waiting 2, 3, or 5 years. And also, the reduction of variance. So by understanding and creating precise maps of soils, we could also eliminate this high covariance, the stratification within the projects. So overall, as we can see, the technology itself is aimed at the increase of the accuracy. And yeah, speaking about the accuracy and how is it used, I would like to pass it over to Oleksandr. Yeah, you've been in the background for quite some time. So, Oleksandr, could you please tell us from the more scientific point of view, what models we use, what kind of predictors, what kind of data sets these models include, and actually how simple or complicated the technology is overall, I mean, from the scientific point of view.
Thank you, Yevgenii. The first thing you have to do when you want to estimate the soil organic carbon with the models is to select the model type. And there are two main types of the model which you can use for soil organic carbon estimation: process-based and empirical models. The process-based models describe the main processes in some domain, the landscapes, for example, according to our target objective. Usually, these models is pretty complicated, while empirical model is typically simpler and developed based on statistical data, based on ground samples. In our project with AgriProve, we decided to combine these two types of the models. And with the following slide, we're going to show you our main concept. On this slide, you can see our main core of soil organic carbon prediction in the next 5 years, based on two scenarios: business as usual and sustainable soil management, with some additionality, as you know. For this purpose, we use a ROAD-C model. On the left side of this slide, you can see the main input data for ROAD-C model: the management, some weather parameters, soil parameters, soil clay, for example, and of course, the initial soil organic carbon content. And this one of the main input parameters should be clarified as best as possible, because the quality of the model results in the future directly depends on this initial soil organic carbon content. And of course, it is obvious that to get the best and high accurate initial soil organic carbon, we need the actual data from ground samples, which are very expensive and also time consuming. And that's why our solution is to collect the ground samples as much as possible and then apply machine learning model. And this is the point where we used our empirical approach. And someone can ask us, why don't you use the open source data of initial soil organic carbon content? And with this slide, we give the answer. Here are the results of comparison between soil organic carbon initial got from ground samples in laboratory and soil organic carbon data from open sources. And as you can see, there is pretty much difference, which can lead to high uncertainty of prediction. So that is why we emphasize our efforts to build solid and reliable machine learning model to clarify the initial soil organic carbon content. On this slide, you can see the simple scheme of our machine learning model. As any machine learning model for regression task, it has the predictors and target variable. Our target variable is soil organic carbon content, initial soil organic carbon content. And our predictors consist from 4 different types. Predictors based on digital elevation map, satellite-based predictors, soil predictors, and climate predictors. And with the following slides, we show you some example of these predictors. Here you can see some predictors generated from digital elevation map with Saga and GrassGIS modules. Usually we split this type of predictors in 3 classes: topographic, hydrological, and solar predictors. And here a couple examples of these predictors. The first one is topological, so-called vector ruggedness. And this vector ruggedness measure provides a way to measure terrain ruggedness. Slope and aspect are captured into a single measure and used to decouple terrain ruggedness from just slope or just elevation. The next one, topo parameter, is plan form curvature. This is perpendicular to the direction of the maximum slope. Next, flow accumulation contains the absolute value of the amount of overland flow that traverses each cell. The topographic wetness index. This index is really steady state wetness index and is highly correlated with several soil attributes such as horizon depth, silt percentage, phosphorus, etc. The next is solar predictors, beam irradiance and ground reflected, which also can be pretty helpful for initial soil organic carbon estimation. As for example, beam irradiance has a significantly higher variability in space and time in comparison to global irradiance, and helps to describe the canopy variation, and as a result, can describe the potential of soil organic carbon content. The next type of predictors is satellite-based. And here's the example of optical predictor. And one of the important things, when you generate predictors from the so-called high variable or extreme variable parameters in time, it is necessary to remember and note that organic carbon in the soil itself is not extremely variable in time. And as a rule, you can observe the changes of soil organic carbon content in time step of 6 months up to 5 years and more. So just to cover the variability of soil organic carbon content, we have to fit our predictors to the same time step of variability. This is very important thing. In this example, to create optical predictor in the correct way, based on vegetation index, in DRE, for example, we take the maximum value per each year of at least 3 or 5 years period prior to ground sampling and average these maximum values. In such approach, we align our predictors with temporal variability of soil organic carbon content. The soil type of predictors. For this type of predictors, we use different soil properties as well as soil type. And based on FAO soil classification map, the territory of Australia covered with 40 types of soil. On this slide, with green color selected the most widespread. most widespread soil types, which cover more than 85% of territory of Australia. And to clarify some soil parameters, we also use simple linear regression based on ground samples and open source data. Yes, and last but not least, of course, the climate type of predictors. And here the same approach as with satellite-based example. In order to align our weather parameters with soil organic carbon temporal variability, again, we have to use so-called two-level averaging method. In this example, we have 3 years period. For each year, we take the average of mean temperature per each season, with further averaging by the whole period. And such method applied to any weather parameters, except precipitation. In case of rainfall, we take the sum instead of mean. So, and this is it from my side. And maybe it looks a little bit complicated, but we try to do the best and try to create a powerful model which helps to clarify initial soil organic carbon content and soil dynamics. So thank you for attention. I pass my word to Yevgenii.
Thank you, Oleksandr. And it does look a little bit complicated. That's why we need scientists to be able to assist us here with these complex models. Because, yeah, the problem that we have, the challenge that we have is not simple, it's complex. So the solution also cannot be simple. That's why we have to have best minds in our corner to be able to leverage the technology and being able to apply it for our purposes. And to sum it up, yes, Oleksandr said the main thing here that we use two models. So one model, we call it SOC model, so organic model, which comprise different machine learning models like regression trees or neural networks and so on. Another model, so the first model, SOC model, is used to create the baseline at the beginning, so to create the accurate map of the distribution of the SOC. And the second model we use for the prediction. So once the baseline is established, we could use ROC model, and this model could ask prediction what would be the content of soil organic matter in 1, 3, 5, 10, 20 years, depending on the different scenarios, depending what practices farmers will do on their land. Either it's pasture or it's agricultural or horticultural projects and so on. So basically, it will allow us to have to run different scenarios to see what practices could basically better contribute to sequestration of soil organic carbon. And yet the second model, so the validation, this is actually when we can save on physical samples. By using ROC model, we could actually eliminate the significant number of the physical samples which are needed for validation and verification. And Oleksandr was showing predictors that go into the model, and there is a lot of different predictors. And in EOSDA, we could use up to 140 predictors. So this is huge amount. It doesn't mean that we're going to use all of them in the model, because in the model we will use only those predictors which will show us the most accurate data. So basically, we will eliminate all the irrelevant predictors, and we will only use those which are the most significant. And among those significant, as we can see, there is some must-have data. This is soil data, soil samples. This is actually what AgriProve is doing. They're taking samples on each of the property, on each of the projects to establish accurate baseline. And then based on the samples, we could do the calculation and actually develop and create these accurate models. And the advantage, the novelty, what we're doing within these projects here, this is the application of high-resolution optical and SAR data. This is the introduction of new predictors such as vegetation indices, NDVI, NDRE, digital elevation maps. land cover data, and so on. So basically, a lot of predictors go into the model to make sure that at the end we will have the most accurate results. And the reason that we use ROTC model, because this model is been already used and tested on different continents. So this model is already showing good and robust results. And what we did in EOSDA, we enhanced these models. So we have some improvements in comparison to the base model, to the ROTC model. For example, we could use higher resolution of satellite imagery up to 10 meters in comparison to 1,000 meters to the base model. Also, we have pipeline which allow us automatically select the most accurate predictors, so which is significantly reduces the time and efforts for developing the model, because the model that is good for example, Australia is not going to work in other parts of the world, for example, in Europe or in Latin America, and the model needs to be adapted to the conditions, to the climatic zones of each of the projects, meaning that for each of the locations, we would need to adapt the model. And in EOSDA, yeah, we could use different methodologies, and our calculation are compliant with the most of the methodologies, for example, like Clean Energy Regulator in Australia, or we could do the calculations compliant to Vera Golden Standard, basically methodologies and others. And yeah, if we sum up everything that we said today, so the purpose of what we are doing here and what are actually the outcomes for the farmers and the carbon project developers and basically for the climate overall would be the enhanced data accuracy, the increased project viability and profitability, and reduction of verification cost. So what we will do and what we will provide for the farmers here, this is the access to visualization of their data, what actually happening on their farm, on their land. So they've been able to see precise soil maps and precise soil organic maps. And by leveraging this data, AgriProve will be able to provide the most accurate recommendations, what practices need to be done or what practices are contributed to the profitability of the projects. As well as will help us to basically promote these practices and engage more of the farmers by reducing the level, the threshold of entry fees for these projects. So as we can see, so the main point is to leverage technology and make it more scalable. But yeah, speaking about the scale, yeah, I would like to pass it over to Andrew. And Andrew, if we're speaking about the scale, so how and basically what needs to be done, so basically to bring this technology on the larger scale to combat this climate change problem. Yeah, Andrew, you are muted. Yeah, I see that you're carrying on.
Sorry, is that better?
Yeah, we can hear you now. And yeah, we could see this smiling farmer, and this is basically the purpose, the whole purpose is to deliver the solutions for the end users.
Yeah. No, thanks, Yevgenii. Yeah, I'll cover what we've covered to date and where to next. So yeah, we've really looked at how carbon projects work and the broader benefit for the farmer, as well as the environment and future sustainability of agriculture. And it is an exciting and continually evolving space. It's definitely moving fast. We've explored the application of a novel SOC model as an addition to the monitoring and management of soil carbon projects. And this is an area will also continue to evolve as AgriProve and EOSDA continue to work on it, and really looking at the broader impact it can have in many areas. So to help explain, a robust and accurate SOC model can provide extensive value for the farmer for a soil carbon project. For the farmer, it can provide a vital link between the actions undertaken and the response, being able to validate and track farm management practice change, see more in more detail as it's happening and understand it at more of a site-specific level. Furthermore, being able to view back and get an understanding of the history, even prior to the management change, can also, also being able to forecast forward as a prediction tool can really be useful in making those decisions as a decision support tool. Beyond this, it can provide information not just about your farm, but also as a comparative tool to assess performance against other similar farms or regions, soil types, conditions, or management practices. So that ability to compare is really useful. We've also highlighted the importance of soil carbon and soil health as an indicator of overall health of a farming ecosystem and relationship to broader climatic consequence. By having this type of information at your fingertips, it can help provide a deeper understanding, as well as focus or bring focus on actions that not only support farming profitability now, but also that longer term farm resilience, farm security, and environmental outcomes. So equipping the farmer with this needed information to help them make informed and really balanced decisions for economic and environmental reasons. And for us at AgriProve, this model assists in a range of areas, from finding areas that lend themselves to soil carbon projects, the setup and initiating of a project that we showed earlier, and also the monitoring and management through the life of a project. Having a robust and accurate measurement tool that can see at scale, as well as validate more on a site-specific level, really helps us to deliver validated and sound carbon credits. Another big piece here that we covered was under the Australian carbon method, being able to stratify a project well provides confidence in the measurement and ultimately maximises the potential ACCU yield. So being able to accurately assess a project in real time saves expense in sampling and does promote more ACCU delivery and revenue from the farmer in the long run. Being able to assess the performance and causal drivers at a project by project level helps deliver insights that support the management actions on these and future projects as well. And really understanding what works where and why. So, I think that's a pretty big summary and a good summary, but all these aspects combined, this novel SOC model that we're working on really is a pathway to help us maximise sequestration through soil organic carbon at a local level and even at a national and potentially even global scale. It really, is needed and helps us act local, but really we're trying to impact that scale, as you mentioned, Yevgenii. So something that we see as necessary to foster the agricultural resilience and prosperity, and also tying back right where we started to make a meaningful impact on climate change as a whole.
Thank you, Andrew. And now, under this summary, let's go to the Q&A session. And here, Kirill's have collected some good questions here. So, Oleksandr, I would like you also to turn your camera and mic on. And I will ask the questions. And guys, if you feel like you would like to add some comments to the question, so please feel free to do it. The first question is this project in Australian based? Mean if I implement or work on it in my country? I will take this question. So I understand that the question is if similar projects could be done in other countries, and the answer is yes. So basically, carbon projects are developed in different countries, and if we speak about the models, so the models could be, we have them ready and we have them working. So basically what we need to do, we just need to adapt the model according to the conditions of the region, of the new region. So if we have model which is working for Australia, meaning that we do not need to adapt the model anymore. So the model will eventually become more and more accurate. But if we are doing the projects in some area where the model hasn't been calibrated, so in this case here, we need to do the adaptation. But the projects here, they could take place anywhere in the world, globally, and not necessarily like only in Australia. If you're in Australia, so please feel free to reach out to AgriProve and they will take care of you guys. And I think, yeah, the second question is to you, Andrew. Do AgriProve customers get real-time access to this data? Is there a support to analyze this data to gain practical farm management insights?
Yeah, so in short, yes, we're providing more and more data to the farmer through the Soil Carbon project. And it's an area we're continuing to evolve and develop further. So yeah, anyone out there that's interested in a Soil Carbon project, please reach out to us and we can take them through more of those pieces. And also jump on our website and you'll see some of those pieces as well. So this SOC model in what we've talked about today in more specifics is something that we're primarily using to set up our projects and the internal work, and we're building out now. So yeah, please stay tuned to provide it in various forms and tools and systems that will allow the farmer to access and use as part of their Soil Carbon project as well.
Thank you, Andrew. And yeah, the third question is also for you. Do PhD students have a chance to do their research project in collaboration with AgriProve?
Yeah, great question. Yeah, please reach out to us. We're doing research in a number of areas. So yeah, depending on your field of expertise and interest, yeah, there could be a fit. So please jump on our website or reach out to us. The details will be coming up next, and get in contact.
Thank you. And the fourth question, yeah, I think it's a broad question. So Andrew, I will ask you to comment as well, and I will comment this question as well. So the question is, what sort of industries or background of individuals would you consider to partner and collaborate with? So basically, as I understand, Andrew, what stakeholders AgriProve is open to work with?
Yeah, I mean, from a actual delivery point, we are a Soil Carbon project developer, and that's projects that are in the agricultural space. However, in terms of, I think I read the question correctly in, who do we look to partner with for, continuing to evolve technology, as well as people in the business. Yeah, there's no defined, it must be in this industry or this area, where we're really looking for the brightest minds in these spaces. So, good understanding of soils is really an interesting space and a complex space. Understanding farming systems and agriculture and how that works. As we've looked here today, understanding some of the modelling and those aspects are really important, right through to all the operational parts of our business. So, yeah, if you're interested again, please reach out.
Thank you, Andrew. And yeah, speaking about from EOSDA point of view, and to be open to work with different organizations, and as I mentioned before, we're working with governmental institutions, we're working with businesses, we're working with the private individuals, again, depending on the industry and the subject of interest. If it's, for example, crop monitoring platform, or if this is forestry solutions, or if this is carbon solutions. So we have different solutions, and yeah, if you have some specifics in mind, so please reach out to us, to AgriProve, with more information, and we'll be able to assist you better. Okay, the next question, again, Andrew, is for you. Is AgriProve open to work on some projects in West or Central Africa?
Yeah, at the moment we're really focused on the Australian soil carbon space. We're looking beyond that, probably early days at the moment. So yeah, probably the best response there or request there is, again, please reach out to us. Happy to talk more about the project and the specifics, and whether it's something we can possibly be involved in or not. But yeah, at the moment, our primary focus has been the Australian marketplace and the Australian soil carbon market. But yeah, we're definitely in a phase now where we're looking beyond the borders of Australia. So yeah, please reach out.
Thank you, Andrew. And another one is also for you. You are very popular today. So the question is, how much on-farm investment is required to set up a farming system to manage for the soil carbon plus livestock plus crop in production?
Yeah, that's a probably a multi-level question. So really depends on the farm and their enterprise and what they're doing. And what practice change they're making. So that's on the farmer level. It could involve fencing. It could involve changing their water points. It could involve pasture renovations, investments in their livestock, stocking numbers, all sorts of things. So lots of elements to it. And then in cropping systems, it could be looking at some of their cropping practices, rotations, cover crops, all sorts of other areas. So yeah, difficult to put specific costs on it. And probably another element of that question is what the cost of doing a soil carbon project is. And the way we structure that is we do a risk share and success, where the ACCUs that are generated, the farmer keeps and retains 75% of those and can choose what they want to do with those. And AgriProve retains 25%. And the costs for the landowner are really the baseline sampling costs. And then from that point on, AgriProve looks after all the subsequent sampling and costs involved in that.
Thank you, Andrew. So guys, if you have maybe specific questions and would like to understand the options of participating in carbon projects, please feel free to reach out to AgriProve, to Andrew, and they will be able in more detail to explain you about the basically how it works and what is the roadmap for the projects overall. So yeah, the next questions, are there any challenges you may have faced when transitioning to carbonization soil practices and dealing with the change, whether with farmers or from your innovative approach? So I think, Andrew, maybe you could also comment on this if we're speaking about carbonizing soils practices and basically dealing with the change, whether with the farmers or from the innovative approach.
Yeah. The structure here is really the land is under management by the farmer. So really it's their choice on what they implement on their farm and how they go about it. We definitely see a range of approaches and ideas and ways of doing it, and a range of appetite for technology and for practice change and things like that. I must admit, from the people that we've seen engage in soil carbon projects, the farmers, they are quite a creative and naturally innovative bunch. And they're always looking at new ideas and challenging the status quo. And yeah, I don't think anyone has all the answers, and that's why it's great to work collaboratively and really learn from each other and continue to evolve these approaches and practices. And also what is really important here is the data is, as we continue to grow the portfolio of projects across different areas where, and again, we're on the earlier parts of this, but we continue to be able to see more trends and gain insights into the different conditions and the requirements and what really works to sequester carbon. So.
Thank you, Andrew. Yeah, I think the main challenge is to convince at the beginning when nobody was working this path before and been able to show the actual results at the end. So I think that there is always would be those who early adopters who will go and do it first, and then the rest majority will have a look at the examples on the success of the existing projects and will follow along. But yeah, I think the main challenge, at least at the early stages, is to convince and basically have farmers to participate and actually see it through. And yeah, the next question is for Oleksandr. So the question is, how have different crops sort of responded to the soil carbonization in various climate conditions? So basically, as I understand it, so like what is the response of different type of crops in different various conditions for absorbing CO2 and sequestration organic matter? If you could, Oleksandr, comment it, please.
Yes, thank you for the questions. First of all, the wet climate is always more favorable to the soil organic carbon increasing. So if we talk about climate condition, it's always the wet climate is better for soil carbonization. The dry climate is not good for soil carbonization. This is the first part. Compared to the crops, there are cash crops and cover crops. The cash crops is bad for soil organic carbon increasing. And the cover crops is good ones, such as buckwheat, lucerne, mustard. They increase the soil organic carbon, increase the carbon in the soil. So.
Thank you, Oleksandr. So yeah, I mean, from your answer, we could once again see that cultivating of cover crops is really important, like one of the practices which contributes. And also, Andrew, maybe specifically for Australia, like what are the major crops that, for example, you have your the farmers that you are working with cultivating, and basically if there is some that better contribute to the sequestration.
Yeah. I'm not sure I can comment on crop types, but we can definitely talk about some practices and some trends that we're seeing. It's interesting. We haven't, one of the big, the big expectations or what the earlier science suggested is that Oleksandr has suggested that higher rainfall would equal higher sequestration. We haven't seen that play out so far in Australia. It hasn't been that tight a correlation. There's definitely some correlation there, but not a tight direct correlation. We really investigated earlier on more, and this is in grazing systems, mixed species, pastures, introducing more legumes, things like that, and saw some good results. But interestingly, probably the biggest gains we've seen to date, and some of the biggest impactors in a grazing system has been the management of the livestock. So how intensive the particular areas are being grazed, how long they're being grazed for, and then how they've been rested to really control, manage the plant growth and the plant activity and keep it in various growth stages. We've seen probably some of the biggest gains in soil organic carbon so far.
Thank you, Andrew. And yeah, the next question, I don't know, it's kind of a broad question and could be applicable for AgriProve and EOSDA, but again, Andrew, I will address it to you. And let's assume that we're speaking about Australia and your projects. The question is, in various regions you worked in, what was the main highlight, successful implementation and engagement? So if we're speaking about Australia and basically projects that you've done, and I will turn back the map on to highlight the projects that you have. So if you could comment, like what regions and what is the level of success in different regions?
Yeah. As you can see, we've got a lot down the eastern coast of Australia, and there it does follow the soil, the soil types of the agricultural production areas. But as you can see, we've got pretty good spread across a number of those regions. So it's probably difficult to call out one particular region. We definitely see clusters of farmers and activities, and I think it's that a community around it. You get one farmer that will start a soil carbon project, and they're talking to their farming friends, farming colleagues, and they tend to work well in a group. So we do see various clusters. In terms of success on projects to date, you can see where the projects in the red dots where we've created ACCUs, as well as the yellow dots, ones that we've calculated and measured increase and just going through the final stages, are pretty well spread as well. So yeah, we've had, I would say, pretty good broad spread success today.
Thank you, Andrew. And yeah, the next question, I think that would be for you, Oleksandr, to cover. Have you calibrated the satellite data with the land-based data?
The satellite data we used is already calibrated. This is from optical satellites, Sentinel, for example. So this data already calibrated, and we use this data as the predictors. So, and maybe I cover in the next question with the opportunity of satellite data to deal with depth estimation of organic carbon.
Okay, so yeah, let me read this question. And again, yeah, this is a good question about the different depth. So yeah, please feel free to comment. So the question is, the AgriProve soil coring to 100 centimeters showed that 95% of the SOC was in the top 30 centimeters. So this means that the largest opportunity for soil organic carbon increase is in the bottom of 70 centimeters. So the question is, what has satellite technology got to assess the opportunity at the depth? So Oleksandr, if you would like to go ahead.
So first of all, what I want to say is that we cannot use satellite data directly to measure the soil organic carbon, of course, but we can estimate soil organic carbon indirectly through the biomass, and that's why when we create the optical predictor, we use a long period, and as a basis, we use some vegetation indices, and we see where the vegetation indices have a high value along with some big time period. So potentially it's lead to what does it mean, high value of vegetation indices? It means that the above ground biomass is also high. So it's lead to, it means that more biomass, more residuals, then these residuals decompose and come to the soil in the form of soil organic carbon. So in such way, the residuals of crops increase the soil organic carbon. And of course, the more biomass, the more residuals. The more residuals, the more soil organic carbon. And we can check it and observe through the satellites. And when we estimate and when we observe the long time period, we can compare and see where the potentially the soil organic carbon can increase in very very large increase of soil organic carbon compared to some territory where the vegetation indices in the low. So I hope I covered this question. So again, we don't measure soil organic carbon directly with satellite data, just through the biomass, through the vegetation indices. That's the main idea.
Thank you, Oleksandr. And also, Andrew, if you could please comment, is this also the reason why AgriProve taking soil samples at 2 horizons up to 30 centimeters and then another one up to 1 meter, or like what is the reason behind sampling at this depth?
Yeah, there's probably a number of reasons. Yeah, it's interesting too. I think the question sort of suggested that most change was occurring below that 30 centimeter mark, which is not always the case. Generally speaking, there is more carbon at the top of the soil, at the upper profile, than the lower profiles. But in terms of change, often it's those higher areas that are changing, or at least changing first. We're trying to understand how that carbon finds its way down the profile, and there's different science on that, and evolving science in that space. It's definitely some of the older held beliefs are really being challenged now. We do see plant activity down at depth, and with that plant activity, we expect to see change in carbon and organic material as well. To Alexandra's point, the remote sensing is not a direct measure of carbon or soil organic carbon, but remember here we're taking in a whole bunch of predictors, up to 140 predictors, and some of those are climate related, some are hydrology related, and topography related. So through that mix of different predictors, often there's correlations there that we don't automatically come to ourselves with our own conclusion. And this is where a big data machine learning type model is starting to reveal those, to then try and draw how that's occurring. If you think about the topography and the lower spots of a field versus the higher spots, they often relate or have correlations to the soil types, higher clay contents or higher silt contents in those areas. And so they can be predictors or indicators of what the likely soil organic content is there present, but also how it may change over time with the actions undertaken. So it's a complex problem, and we're definitely tackling it from a number of areas. So for us, we can't manage what we can't measure, and so that's why we look to go below that 30 centimeters to really understand it, and continue to build this out further.
Thank you, Andrew. What gets measured get done. So I would like, first of all, thank you, our audience, for the questions and for being active. Guys, thank you so much for joining our event today, and we look forward to meet you at the following events that we will have. Andrew, Oleksandr, thank you so much for your participation. Was really glad to have you here. And basically, to the rest of the audience, thank you so much and have a great day.
Thank you.
Yeah, thank you, everyone.
Thank you, guys. Take care. Bye-bye.
Bye-bye.